Okay, this is the first of about 4 or 5 lessons I'm going to try and rock out here and get up onto YouTube today. So I'm going to try to keep them at a high quality as always. Today, transformations. Okay, let's start out by talking about some different kinds of transformations and leave yourself enough room underneath each one of these. We're going to give you some examples. Transformations here. We got translations, rotations. We're also going to talk about reflections, and lastly, dilations. All right, so let's start off with a translation here. Let's see. If I take this triangle here, a translation would be an exact copy of it, but just moved someplace else. So if I just take this exact triangle and move it, that's a translation. That's a translation. That's a translation. So a translation is just moving an object or sliding an object. A rotation. Okay. How about we go with this trapezoid here? Okay. A rotation of this trapezoid. Let's first of all, let's make a copy of it. And then a rotation would just be turning it. That'd be a rotation. It doesn't matter where we put it, but a reflection. Let's grab a good one here. How about this? Yeah, this little half circle here. A reflection of this guy would look something like this. First of all, I'm going to copy it. And then I'm going to flip it. Let's flip it down like that. So that's a reflection. Oh, some might argue too that that's a rotation, and I don't know that I'd so much disagree with them. Rotation really is more like around a certain point, something like this. Okay, and lastly, a dilation, and we may have talked about this already in class, but let's see, what should I use for this? How about I use this pentagon here? And a dilation would be to not exactly copy it directly, but it's actually to increase the size of it too. So it maintains its proportions, but it gets bigger. That's a dilation. All right, so I think we got these 4. This will summarize them a little bit more. For A through D, write the meaning of each transformation by selecting a word from this list: a turn, a flip, an enlargement, or a slide. A translation, I used this word on the previous slide. It's a slide, where you just kind of slide things around. A rotation, that would be a turn. You're just turning an object. A reflection would be like flipping it. And a dilation would be an enlargement. Oops, sorry about that. So we got a slide, a turn, a flip, and an enlargement. Okay. Rectangle PQRS is dilated with a scale factor of 3, forming rectangle. And here's how we say this. These little apostrophes here mean you say them as prime. P prime, Q prime, R prime, S prime. Use this information for E through G. Sketch rectangle P prime, Q prime, R prime, S prime, and label its length and width. So when you enlarge a figure or dilate it or increase its size by a scale factor, you create a new image, and usually this is kind of how they're named. So let's sketch the rectangle first. P prime, Q prime, R prime, S prime. Notice they all stayed in the same place. And if we're going to dilate it by a scale factor of 3, then we multiply all the dimensions by 3. 6 times 3 is 18. 4 times 3 is 12. So the new dimensions are 18 centimeters by 12 centimeters. It's obviously not drawn to scale, but the dimensions are listed to scale. So this side should be 3 times longer than SP. S prime, P prime should be 3 times longer than SP. All right, and this one pertains to the previous image too. The perimeter of the dilated image is how many times the perimeter of rectangle PQRS? Okay, let's first I'll figure out the perimeter of PQRS, or perimeter 1 would be 6 plus 6 plus 4 plus 4, which is 20 centimeters. So the original figure had a perimeter of 20 centimeters. S prime, P prime, R prime, Q prime, or perimeter 2 we'll call it, would be 18 plus 18 plus 12 plus 12, which is going to be a perimeter of 60 centimeters. So to answer the original question here, the perimeter of the dilated image is how many times the perimeter of the rectangle? Well, 60 is 3 times 20. So this perimeter is 3 times as large. And remember, the scale factor was 3 as well. So it's 3 times larger. Let's see if that holds up with area here. The area of the image is how many times the area of rectangle PQRS? Okay, well, the area of PQRS would be its base 6 times its height 4, which is 24 centimeters squared. And the area of P prime, Q prime, R prime, S prime would be 18 times 12, which is 216 square centimeters. Well, 24 times 3 is not 216. Okay, so it's not 3 times bigger. So how many times bigger is it? It's actually 9 times bigger. 24 times 9 is 216. And here's why. Area is 2 dimensions, so it's actually not 3 times bigger, it's 3 times 3 times bigger. So it's 3 squared times bigger. If we use the scale factor of 4, then the area would be 16 times bigger. If we use the scale factor of 5, then the area would be 25 times bigger. If we use the scale factor of 9, then the area would be 81 times bigger. Perimeter, though, is just 1 dimension, so it's the same as the scale factor that it's going to increase. That's all I got for you today. And I'll see you tomorrow so we can do the problem set.